All right, in this podcast, we're going to start looking at the strengths of acids and how we can explain and predict those strengths. All right, so first let's talk about conjugate pairs. We touched on this a little bit, but basically the stronger the acid, the weaker the conjugate base is going to be. So very weak acids have very strong conjugate bases. Very strong acids have very weak conjugate bases. So they're kind of like inverses of one another. And if you have like a middle of the road acid, it's going to have a middle of the road conjugate base. All right, so here's just a kind of like a visual. Very strong acids, so acids are getting stronger as we're moving up, which means the bases are getting weaker as we go up. So they are stronger down here at the bottom where they have a weak acid. Okay, so the strongest base in the reaction is always the one that is going to accept the protons. Remember, there's always going to be two bases in the reaction. You got the one on the reactant side, and then you got your conjugate base on the product side. All right, so here we have HBr, which is a strong acid reacting with H2O. So in this case, H2O is the base, and H2O is accepting the proton. What's what makes it the base. And then this guy is competing in the reverse reaction to get it back. So this is going to be your conjugate base over here, conjugate acid. Okay, so when we're talking about this, the water as the base and Br minus as the conjugate base, water is definitely going to be the stronger base here because this Br minus is the conjugate base of a very strong acid. So this is a very weak base, which means H2O is going to be stronger than it. All right, and then the opposite is true if we're looking at weak acids. Okay, so in this example, you see we have NH4 plus and H2O. NH4 plus is your acid in this case, and it's the one that gives away the proton. And then H3O plus is, again, your base. It is accepting the proton. Okay, so now when we're comparing, we have let me just label these. So we have our acid, our base, and then our conjugate acid and conjugate base. Okay, so we're going to compare the strength of water as the base to NH3 as the conjugate base. So in this case, NH3 is going to be the stronger base because it is the conjugate base of a very weak acid. So very weak acid needs a stronger conjugate base. So this one's the stronger base in this case. All right, and last but not least, we have a little example problem. Okay, so you see we have three acids here, HI, HCl, H2SO4. They're all known as strong acids, but we are asked to rank them from strongest to weakest based on their Ka values. So strongest is definitely HI, and then HCl, and then H2SO4. Okay, so strongest over here and weakest over here. And this is, again, all based on how big that Ka value is. All right, now it wants us to rank the conjugate bases from strongest to weakest. Okay, so remember, it's like an inverse relationship here. So the conjugate base of HI is I minus. So this was the strongest acid, which makes this the weakest of the conjugate bases here. Okay, and then we have HCl as the acid to Cl minus as the conjugate base. This guy was the middle of the road, at least with these three. Acid in terms of strength, so again, his conjugate base is going to be kind of middle of the road here. And then we got H2SO4 with its conjugate base, HSO4 minus. This was the weakest acid, which makes it the strongest conjugate base.